Reflection nebula. A reflection nebula is a cloud of dust that does not create its own light. Instead, it shines because nearby stars illuminate it. The dust particles scatter starlight, often giving these nebulae a soft blue appearance since blue light spreads more easily through fine particles. Reflection nebulae are commonly found near young stars that have recently formed from the same cloud of gas and dust. They help astronomers study how stars are born and how stellar environments evolve over time. Emission nebula. An emission nebula glows because its gas has been energized by nearby hot stars. Powerful ultraviolet radiation strips electrons from atoms within the cloud, and when those electrons reconnect, the gas releases light. Hydrogen is usually the most abundant element present, producing the characteristic red and pink colors seen in many famous nebulae. These glowing clouds often mark regions where new stars are actively forming. Some of the most recognizable images in astronomy belong to this category. Planetary nebula. A planetary nebula forms during the final stages of a medium-sized star's life. As the star runs out of fuel, it sheds its outer layers into space, creating a glowing shell of gas. Early astronomers gave these objects their name because they appeared similar to planets through small telescopes, though they have no connection to planets at all. At the center sits a hot stellar remnant that illuminates the expanding cloud. Planetary nebulae reveal what may eventually happen to stars like our Sun billions of years from now. Dark nebula. A dark nebula is a dense cloud of gas and dust that blocks light from stars located behind it. Instead of glowing, it appears as a dark silhouette against brighter regions of space. These clouds can contain enough material to create entirely new generations of stars. Although they seem empty when viewed with visible light, infrared observations often reveal hidden activity deep within them. Dark nebulae remind us that some of the most important events in the universe happen behind thick cosmic curtains. Molecular cloud. A molecular cloud is one of the coldest and largest structures found in galaxies. It consists mostly of molecular hydrogen along with dust and trace elements. These immense clouds can stretch across hundreds of light years and contain enough material to form thousands of stars. Within their densest regions, gravity slowly pulls matter together until new stars begin to emerge. Molecular clouds serve as the primary nurseries of stellar creation throughout the universe. Protostellar nebula. A protostellar nebula is a region inside a larger cloud where a future star is beginning to take shape. Gravity causes gas and dust to collapse inward, forming a growing central object called a protostar. At this stage, nuclear fusion has not yet fully started, but the young object is steadily gaining mass. Surrounding material often forms disks that may later produce planets, moons, and other bodies. These nebulae offer a glimpse into the earliest chapter of a star's existence. Supernova remnant. A supernova remnant is the expanding debris left behind after a massive star explodes. The blast sends enormous amounts of gas and heavy elements racing through space at incredible speeds. Over time, the material collides with surrounding gas, creating intricate shapes and glowing filaments. Many of the elements essential for planets and life are distributed through these violent events. Supernova remnants demonstrate how destruction can also become the beginning of something new in the cosmos. Bipolar nebula. A bipolar nebula has two distinct lobes extending outward from a central region. These unusual shapes form when gas escapes more easily along certain directions rather than expanding evenly in all directions. The result is a structure that often resembles an hourglass or butterfly. Bipolar nebulae can arise during the late stages of stellar evolution and provide clues about the influence of companion stars, magnetic fields, and rotating gas. Their striking symmetry makes them among the most visually remarkable nebulae in space. Wolf-Rayet nebula. A Wolf-Rayet nebula forms around an extremely massive and energetic star known as a Wolf-Rayet star. These stars generate powerful stellar winds that push vast amounts of material into surrounding space. As the winds interact with older layers of gas, they create glowing shells and complex patterns. Because Wolf-Rayet stars live fast and die young, these nebulae represent a brief but important phase in stellar evolution. They help astronomers understand how massive stars enrich galaxies with heavy elements. Herbig-Haro object. A Herbig-Haro object forms when jets of material from a newborn star collide with nearby gas and dust. The impact heats the surrounding matter, causing it to glow. These objects are usually found in active star-forming regions and often appear as bright knots or streaks. They can change noticeably over relatively short astronomical timescales as the jets continue moving through space. Herbig-Haro objects provide direct evidence of the dynamic processes involved in the birth of stars.